Hi students, a very good morning to all of you. Myself BK Misra, your chemistry teacher. Today I am going to start my third lecture on class 9th chemistry. The chapter is matter in our surroundings. In my previous lecture, that is lecture number 2, I discussed about the in-text questions of NCERT, and today I am going to start a new topic, that is physical classification of matter. Now, what is the physical classification of matter? Matter exists in three states, that is solid, liquid and gas. And what are the properties of solids? What are the properties of liquids? And what are the properties of gases? We will see one by one. Now see here. Solids have fixed shape, liquid have no fixed shape, and gases have no fixed shape. Now, solids have fixed volume, liquids also have fixed volume, but gases have no fixed volume. Now, about the compressibility, we know that solid cannot be compressed, that means it cannot be squeezed. Now, liquid cannot be compressed easily, but gases can be compressed easily. And the fourth point is, and the important point, solids have strong forces of attraction between the particles, but liquids have less force of attraction between the particles in respect to solids. But in gaseous state, we see the least force of attraction between the particles. That is least in the gaseous state. Now the fifth point is, solids have high melting and boiling point, but liquids have low melting point but high boiling point, and in gaseous state they have low melting point and boiling point. Now the interparticle space, this point is also important. Interparticle forces of attraction and interparticle space. Now this is least in the case of solids, more in the case of liquid, and maximum in the case of gaseous state. Okay. Now in solids, the particles are arranged in an ordered manner, that is ordered arrangement of particles. But in liquids, little order of arrangement of particles. The particles are arranged in a little order. But in the gaseous state, there is no arrangement of particles, so they can move to anywhere. They even strike the walls of the container in which it is kept, and it is in the random motion, because they have least forces of attraction. Now see, solids have mostly high density, liquids have mostly less density, and the gas has least density. And in solids, particles cannot move freely. They can only vibrate in its mean position. They cannot move freely because the interparticle space is minimum in solids. Now, in liquids, particle can move because they have more space and less forces of attraction than solids. So, the particle of liquid can move, but the particles of gaseous state move in all direction because they have the maximum space and the least forces of attraction. Due to this property, the particle move in all direction. Now coming to the last point, that is fluidity, the property of a substance to flow. Now solids don't flow, that is they don't flow. Liquids flow from high to low, and gases flow in all directions. It also strikes the walls of the container in which it is kept. Now what is density? Density is mass per unit volume. This is known as density. Now summing up all the points of the solid, liquid and gaseous states, the 3 points are very important, that is interparticle space, interparticle forces of attraction and kinetic energy of particles. On these 3 points we can explain the physical nature of matter, that is solid, liquids and gases. Now students, uh, I am discussing here an activity in which I am trying to explain about what is compressibility and what is the effect of compressibility in solid, liquids and gases. Now first let us define what is compressibility. Now compressibility is the property of a solid or a fluid in which the volume can be decreased by applying pressure. Now we will try to see with the help of this activity. For that we take 300 milliliter glass syringes having frictionless pistons. We apply a little Vaseline into the pistons so that it can move freely. Now in the first syringe, fill it with salt, and in the second syringe, we fill it with water, which is a liquid, and in the third syringe, we have given nothing into it because air is inside, which is a gas. Now we apply a weight, 50-gram weight, on the pistons of all the three uh, syringes. In the first syringe, we are not observing um, any movement in the piston. In the second also, we are not able to observe any movement in the piston, but in the third syringe, when we have applied a 50-gram weight, we observe that the piston is moving downwards. Therefore, we see that the air can be compressed very easily. We see that a large amount of gas, LPG gas, is filled in small cylinders and is being used in our homes, as well as oxygen cylinders are also used in hospitals for diagnostic purposes, whereas CNG, that is compressed natural gas, is also used in vehicles, in cars and buses. Students, now let us define what is diffusion. It is an important term. Now, diffusion is intermixing of particles of different types of matter, uh, which is because of the movement of particles. We know that the particles of matter are in random motion, so they intermix with each other. Now, diffusion in gases. Now we are having here three examples. That is, when we light an incense stick in some other parts of the room, the smell or the fragrance reaches to us when we are sitting at a larger distance also, because the particles of the fragrance mixes with air and it travels to our nostrils, which we are able to feel the smell of the fragrance. Now, when a food is being cooked at a larger distance, the smell of the cooking of food, that also comes to our notice due to diffusion in gases, because the particles intermix and reaches to us. Now, the third example is when we uh, use a perfume, and then the smell or the fragrance of the perfume moves in and around us, and the other people who are close to us or at a larger distance, they also feel the smell of the perfume, because the vapors of perfume mixes with air particles, and this is due to the property of diffusion. Diffusion in liquid. When we drop an ink in a beaker filled with water, we see that the ink spreads all over the water, and the solution becomes uniform, which shows that the particles of ink spreads uniformly all through water by the process of diffusion. This is the example of diffusion in liquid. Many people think that there is no diffusion in solids, but I will like to give an example. When we write on a blackboard and we don't rub immediately, we leave it for say 10 to 15 days, the particles of the chalk embedded into the board doesn't rub out quickly, which shows that solids can diffuse or also diffuse, but the rate of diffusion in solids is very low. It is time taking, so we do not notice it very easily. Now this is all about diffusion, and this is the concluding part of my third lecture, and nice meeting you on my next video.